Good morning, friends, and welcome to ESN Academy. And we are discussing about understanding microprocessor. This is a week 3 and session 1. And week 1, we have generally discussed about chips and all the pins and everything. And week 2, we have discussed about some of the instructions, not all, few instructions. And week 3, we are going to discuss about assembly language programming. Okay. So before we get into the assembly language programming, there were some of the doubts in the previous session. Let me clarify those doubts. Okay, so the basic doubt is with the one instruction. That instruction is there were two instructions are there in 8085. One is, you know, that add. Other one is add with carry. Same way, subtract with borrow. You need to understand that. This is a very widely used instructions. So better understand. What is add? Add is simple. For example, you have, if you write a instruction now, move immediate A, 10. Move immediate B, 20. You say add B. Then what happens? 10 and 20 will be added. 10 and 20 will be added. We get 30. Of course, there's a small confusion. We'll get 30 or not is the bigger issue. We'll discuss. Okay. Here is the trick. When I'm trying to move into the register, what happens is when it goes to microprocessor, this instruction is 3E. This 10 is changed to 0A. Okay, this 10 is changed to 0A. I'll discuss that before we go further. Then move into B is maybe 30 could be, and 20 is 1, 4. Add B. So this I don't know the instruction, maybe some 2A something. Now the trick here is this is getting converted to machine language. Now people have a question. This one is decimal or binary or hexadecimal. Please understand there are only two things are there. One is decimal, other one is binary. We humans accept decimal and the computers and microprocessors accept binary. Okay, so there's nothing, but to make us to, let's say, if you want to write this as a binary, I write like this: 0, 0, 0, 0, 0, 1, 0, 1, 0. The 1, 2, 4, 8, 16, like that. So 8 plus 2 is 10. This is the way I should write. That is boring. What people did, instead of writing like this, 0, 0, 0, 0, 1, 0, 1, 0, they made a shorthand. 0, A. And you have to put H. That means that it's a shorthand. The shorthand name is called, there's a in between these people. The shorthand name is called hexadecimal. So hexadecimal is a shorthand of binary. So there's nothing called hexadecimal. Please understand. You need to expand it always when you see that H. So what is stored in the memory is this 3E will be stored like, actually this is converted to like this. This is not like this. This is converted to movability 3E 0, 0, 1, 1, 1, 1, 1, 0. This is actual instruction. Please understand. And you have written 10 decimal. That has to be converted to 0, 0, 0, 0, 1010. You need to do this. This is what 10 decimal. And this is what the instruction for move immediate A. But you cannot understand, or you cannot study, you cannot read. All are tough. So what people did, they made this as a 3. They made this as a E, 3, 0, A. This is what actual. What is actual? This is what actual. But this is not actual. Please understand. That's why I understood. Is it clear? Is it clear or not? So don't get confused between hexadecimal, decimal, and binary. If you are convenient, write it binary. Sorry, the decimal. But that will be you should convert it to binary when you give it to the microprocessor. But writing that is more, so that's the reason we write this. So this is all binary. There's nothing. The microprocessor never understand hexadecimal. There's nothing called hexadecimal in the history of microprocessor. It's only binary. So we will continue that, then you will understand slowly. That's fine. Correct. Only for us. You are convenient. It is only for your convenient. Not for our, it's only for you, your convenient. You don't, it's all not study. It is for your convenient. There is nobody in the world accepts hexadecimal. Humans accept binary, sorry, decimal, and computers and microprocessor accepts binary. That's all. There is nothing called 16 states are there. Your gates, digital gates, digital understand 1 or 0. Analog understand 1 to 0 to 1, all, everything in between. But whereas there's nothing called you humans understand from 0 to 9. But nobody in the world understand 0 to 15. There's nothing. There's no system. It is make for you to simple your life simpler. Now, let us try to add. See, what is your capability? You can add only 2 single digit. 9 plus 5, 14. But if I give this number 1, 6, 4, 5, 3, 8, sorry, 3, 1, 2, 4. When they give this, normally what we add is 5 plus 4, 9, 4 plus 2, 6, 6 plus 1, 7, 3 plus 1, 4. It's very happy. But here is a problem. The school, the teacher gives first name 6 here. Now what the kid will do? Simple. Even we did it. 5 plus 6, 11. 4 plus 2, 6, like this. If you're a 7, say 8. We write 12 here. We don't understand about carry first time. Then the teacher will tell you that if you add 2 numbers, you should get only 1 number. So the other number you should write it here side. So you get 11. If you get 11, you write 1 here and 1 here. This one comes here. This one goes here. Then you have to put this 1 here. Then add with that. That is what the teacher told us. Am I right? Now we are going to tell the same thing to microprocessor. What we are going to say is that if you say add B, I told him that what you do? You add A and B and put the result in B. If A is 10, B is 20, you put the, A. So A become 30 now. 10 will be gone. 10 will be gone. But suppose if I have here 80, 80 plus 20 is become 100. So what happened? It can store only 2 digits. Now, what will I do the 1? I can throw it up or something. But what that guy does, the processor, he stores he has a register called flag register. He has one register called F, called flag register. The flag register, it stores the number. It stores the number where the flag register is having 8 bits. Okay, this bit is called carry. This bit is called nothing, no use. This bit is called parity. I'll explain later. Nothing. And this bit is called auxiliary carry. This is nothing. 0 and sign. This flag is having 5 sets. Extra register he has. The register means one flip-flop. Each one is a flip-flop. One D flip-flop. Please understand. Every bit when I store, that goes as a D flip-flop. That information is stored here. Now, when I had this number 80 plus 20, it becomes 0, 0. I get a carry 1. That carry is stored now 1 here. Understand? That you can use it later or not to use it. That is your wish. You want to add only the 2 number. Let's say if I write a program, if I write a number, we will see 2 programs in C. Let us write 2 programs in C, and we will see that. Then you will understand. Then you will understand. If I say char A, B, and C. That means that I have 3 variables, A, B, C. When I say char means I store 8-bit. Please understand. When I say char means 8-bit. So A equal to 10. B equal to 20. C is equal to A plus B. Printf understand? Now you get answer is 30. You know that. Now, if I say here 130. 130. Okay. Let's not 120 is too big number. Let us put 129. 129. I've given 2 numbers, 129 and 130. Let us assume 130. That is easy. Just 2 different numbers. If you add them, what answer you will get it? Anybody? For this C program, what answer you will get it? Please let me know. Please let me know. Can anybody? Can anybody? Please pick. We are spending a lot of time. Somebody said different behavior from different compiler. That's typically is a good answer. But unfortunately, we are assuming right now our platform is 8088. We don't go to the ARM platform. We are going to 8085 platform. We are using 8085 platform. We assume that I'm not using ARM. We are using 8085 platform. Now I'm asking. We know that laptops, PCs. On that, what is the answer? There's a trick now. The trick here is you have to know that what this guy happens. When I say move 129, this is getting written into the, when I write this as a program, let us see that how it is getting converted. When I say ABC, okay, in my memory, I allocate 3 spaces. 1000, 1001, 1002. That done. There's no activity. For the first line, I don't do anything. I do only the what? Create a table and I put A of address, A of address is 1000, B of address is 1001, C of address is 1002, because each one is going to occupy only 8-bit. Okay, is it first line? Is it clear? Because I wanted to slowly tell you through assembly language and C. You know C. You always do the declaration. This first line, the first line of declaration, this is what the meaning. Nothing more than that. It does not do anything. The first line does not do any activity other than this. Of course, it's also allocated that what is the size? 1, 1, 1. And also it says that whether it's a signed or unsigned. Okay. You can say unsigned char also. That information also stored. Now we don't need that right now. Forget it. Now, when I say that and A is 1000, this guy will say that move immediate A, 129. I have to convert it to binary. 1, 0, 0, 0, 0, 0, 0, 1. Understand? That has to be very clear to you. If it's not clear, let me know. If that is not clear, let me know. 128 plus 1, 129. When I second line, they say B. So this itself, I'll put store accumulator, store A, store accumulator, where at you ask him to store at what? A. So I put A address is how much? 1000, 0000, sorry, 001, then 00. Because I want you to write exactly in binary. Please understand. Then only you will understand how exactly the programs are executed. Since nobody writes on this binary, you have all the confusions. Then I have given B. I say move immediate A, 100000010. Am I right? Then I store A, I'm storing it to B. B is 1001. So 0001. Am I right? This goes. Now you say you are adding A plus B. Do only the operation. Don't worry about this. You do the operation. You are adding A plus B. I put load accumulator. Where? From where? A first. 000. Let me erase this because this I'll write it later. Okay, or this side. Because the address of A is 1000. Then B, load B, there's no intelligence here. It is just following a procedure. Please understand, learn how to follow the procedure. Then I say add B because you are adding. See how I am translating every line of your code. Add B and add the result. Then you say now the result is at A. Am I right? Now I say store accumulator because add B means A plus B, the result into A. It is already there in A. And you are trying to store it in C. C means store A 0001 10. Okay. Now what is there in the location C? I am printing. So this is actually called some address call. I'll discuss later. Call. I'm calling the function printf. Forget about now. Now I'm not going to give function now. Now see the code. Move immediate A. You change it to binary. 0, 0, 1, 1, 0, 1, sorry, 1, 1, 0. Okay. Then let us have a store A, some instruction. Something. Let us do 1, 1, 1, 1, 0, 0, 0, 0. Move immediate A, 3E, 0, 0, 1, 1. Store A, 1, 1, 1, 1. Load A, 1, 1, 0, 0. Some I'm just giving a binary. Load B, 1, 1. Add 0, 1, 0, 0. Some equivalent instruction. And store A, 1, 1, 1, 0, 0, 0. See that? This is what that. Now, this is confusing for you. This is stored in the first line of memory. This is stored second line. Everything is binary. So your C program is getting converted to binary. That's why we call it, these files are all called bin files, binary files. Or we call bin file. It's a binary file. Please, binary, understand. This is what who executes your microprocessor. This, but in your memory, you can store only one at a time. 8-bit. In your memory, you can store only 8-bit at a time. At 0, 0, 0. So what I stored in the 0, 0, 0 is this. 0, 0, 1, 1, 1, 1, 1, 0. Then 0, 0, 0, 1. I store 1, 0, 0, 0, 0, 0, 0, 1. The second one. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now your program is going to occupy 20 bytes. 0 to 19. It's going to occupy 20 bytes. But you know that, do you understand this? You never understand. This is a very, nobody can understand. So what happened? For that reason, we write into a very simple format. Move immediate A, comma, 10. Okay, 10 means, sorry, we write the other way. Sorry, we write 3E, 10, 0A. Then store, we have some instruction. I have 0 to address what? 1000. So 10, 0, 0. Then 3E, 14. F0, 1001. That is B. This is A. So we write in a hexadecimal way. So that is the reason. There's nothing called hexadecimal. Now, what happened when I store the number in 1000? It is storing 10000001. This is 129. Because 1 to 129, 128. Next is when I store B as 130, 128 plus 2. Then I'm adding. When I'm adding 1 plus 0, 1. 1 plus 1, 1 becomes 0, 0, 0, 0, 0. 1 plus 1, 10. I add 0 here. But for your convenient, our man store the carry. He is not destroying. He will store it on the flag register on the carry bit 1. That is set. But what you are doing, this is C. You are storing it in 10, 102. That is what this. Unfortunately, without worrying about carry, you do printf %d, comma C. What our man will do, a C is 1002. He will take this, the printf, and print it. You will get answer 3. You will get answer 3. Am I right? This, if you're going to confuse you, let me know, because I told you, I'm not in a very serious hurry. We can take 1 or 2 class extra also. Okay, but better understand. Without understanding, going. I also completed 80, 85 understanding, and finally I don't understand. That's not right. Please. That's why I'm not interested to go forward fast. Do you agree this? If anybody have anything, why the answer will not be 3, then you know that. If you want, I can even, we will write a code and see that. 1 minute. Let me share that. Let me share our code block. But I have to see that. Somebody said that it will be different compiler, different thing. I have to see that, how it is. I have not yet, maybe. They might have seen that. That's fine. Let me share the screen. I hope you're watching, you're seeing my screen. I should not share it and then write it. Is it clear? Compile it. I get 0 errors and 0 warnings. Print it, you get 3. Okay. So here also there's the execution time. That's fine. And I get 3 now. Understood. So please understand this. This is what I'm trying to explain to you, that how that compiler will behave. So I've shown the thing. Now we will try to write the same program in a simulator. Okay, let us see the thing. I have a like a C. We have an assembly language itself. We use a simulator called Sim8085. It's called Sim8085. It's available in the net. The site itself is called Sim8085. Okay, sim8085.com. Okay, see here. Here, this guy shows all the registers. Okay, A, process word. That is F. This is called flag. Flag register is called PSW. Okay, A is accumulator. So here, the 02 is PSW and 00 is A. Then BC and DE and HL. This is called stack pointer. This is called program counter. We will discuss later. And there's a flag. See here, 0, sign, parity, carry, and auxiliary carry. Let us write a small program. Let us write our own program. Let us see how this case behaves.
Screen is not visible.
Oh, sorry. Is it? Oh, thanks. I thought I'm sharing that. Thank you. That's why now I do. What mistake I've done? No, I shared. Is it visible now? Is it?
Yes, sir.
Oh, thank you. Okay. I was explaining only this registers. This is A and PSW. That is called flag register. The PSW is flag register. They call process status word. Then BC is B and C. This is a B register. This is a C register. Then DE and HL. Then stack pointer. We will discuss very detailed about stack pointer. If you understand on 8085, you will understand on 8086 on the ARM and everywhere. This is very important. You should know that. This is what we use it on the storing local variables and PC. So this Sunday 2 hours will actually will benefit you in the long run. You will be very surprised. Then this is called flag register. I have 5 flags in 885. 0, sign, parity, carry, and actually we'll discuss all those things one by one. Right now we are discussing only about carry. Now I write a program here. Okay. I write a program, move immediate A, comma 10. Okay, I'm moving 10. Then store A, comma 1000 H. Let me make it a H because I don't want to do it on a decimal. Then I say move immediate A, comma 20. That's what we discussed. I can even start the other one, my screen. So what we have written was our program is this. Our program is this. Move, char A, B, C. Then A equal to 10. B equal to 20. C is equal to A plus B. I'm writing so big because somebody who is watching in a mobile phone, if I write it small, this becomes too small. That's why I'm making it right big. Okay, this is what we have written. Now, we ourselves put a table. We say that instead of compiler ourselves, we ourselves put a table and we have written and A 1000. We say our address. And B is 1001. And C 1002. And these are all hexadecimal, 0x. Understand? It's not binary, it's not decimal. Now I'm writing a program now. Then I say move immediate, store accumulator 1001H. Then I say load accumulator 1000H. I'm reading from A. Then I say load accumulator 1001H. Add B. Sorry, I did a mistake now. Now A is getting gone. Now I say move B, comma A. I'm moving the A to B. Then I say load accumulator 1001H. Then I say add B. Now we'll see that one by one. We'll execute line by line and see the code. Then I've seen now store accumulator at 1002H. I mean, we have written now. So I've written this program, what I have written in C, now I have written it on this one, assembly on 8085. Now let me compile it. Let me run it. Okay. Assemble and load the program. See that we are loading at location 80. That is what this software does. The SIM 8085 is loading at 8000. Now I am assembling it. See that. I have assembled. Now it is loaded. You want to see that where it is loaded? You can see here. Yeah, now your code has been compiled and loaded into memory 0800. Now we'll see that. Now let me not show this. Now we'll see here. This is what your code, man. Whatever code I've written, see that 3E, 0A. Now you say this is a nice way they have done it within the single page. You see that the 0x80 is the address. It's very difficult for me to explain anything without on a board. I've been addicted to the board. I cannot speak and explain to you now. Now you see that your address is 08800. What they have done is clear. They made it as a 0x, sorry, 080, 08. Okay. This they made it at one line. Then they display 0, 1, 2 like that up to F. That means that this location is 0x0800. This location is 0x0801. This location is 08080F. I can change the address as you wish. You can view the entire memory, 64K memory, by displaying here 0. If you say 0, see that it is showing me entire 0, 0 to FF, up to FF. See here, this is FF. It shows. Now, if I say now, here FF 00, that means that FF00, FF01, like that, I can see the entire memory of FF. So now let us see the program. Our program is loaded in our program is loaded in 0800, 3E, 0A. 32 is called load. This one, what? See, 3E is called move immediate A. 32 is load accumulator. So store. 3E is once again load. That if you have a confusion, you come down. They've given explain that also. This is a very good. That's why I say that. You see here now, your assembly program, what I have written now. These people have shown each and every one what is the equivalent output. Do you see that? So this code gives you all. That is, it shows me the assembly instruction. Yeah, that is right. But the problem is 00 is ROM. I cannot write anything. That's why they made it as a 800. Okay, that is what this software people have done it. I think there is some reason for that. Okay. (0800) is starting address of RAM. That's why they want to store that. We'll see that. I'll let you know that why they have started. I also thought about it today morning, and today morning only I saw that before coming to the class. I've not used this system because I've used the real board and real things. Let me see that why they have loaded at 800. I'll give you. I owe you an explanation for that. Right now I don't know. Okay. So think of it. Now I go back here and this is what I see the code. Then let me try to explain. Now what is the registers? All the registers 0000. Am I right? So all of them are 00. Only PC is at 8000. See, they don't allow me to change this too. See that? Software. I don't know why they fixed it at 800. I have to read the document. Let me do that. Okay. Next class, I'll explain to you, or in the WhatsApp, I'll explain to you that. So now, let me execute this. See, all the flags are not set. Now let me execute the instruction one by one. This is called all the program. This is called one step. Let me go by step. I'll go one. First step. See here, it selected this instruction, but not yet executed. If it executed, A should have been 10. Now A is 0 only. See here, A is 0. Now I execute this instruction. Now I go to second instruction. Now first instruction executed, A becomes 0A. See that? Now I execute the next instruction, store. Then you go to the C and 1000. Let me see 1000 now. See 0A. Now the memory location 1000, that 0A is stored. Yeah, correct. We have to write a halt. Thank you. Let me do that. I do the mistake. Okay. Okay. I will show only up to the step and stop. Otherwise, he get confused. Am I right? Let me stop it. He said, fine. Somebody has, I think, worked on this software. They remind me here, halt. But you'll be very surprised. From the moment you learn this programming, we didn't have this tool. When we were studying nothing, today you have everything. All are free. This is all free. You will understand 8085 in one tool. If you spend about Saturday and Sunday, you will master it, man. There's nothing more than that. It has to master only 2 days. I'm explaining very slowly, but you can do it in no time. Now I start from beginning. I'll stop. I compile because I modified it. I'll start the execution, the first step. Now what is, see that all the registers are 0. I didn't make it 0 now. I have to make it 0. All the registers are 0. Okay. And the program initializes stack pointer to the last one. Now all the no flags. Now let us see the address 1000. What is there? A is there because I didn't reset. And there is a command here to reset all of them. Am I right? This guy. Yeah. Let me do that. I stop and reset. That will be very good. If we reset, everything is reset. Now, see that all are 0 and memory also you should reset. Yeah, 0. So I need a reset now. So this is what reset. You start from a scratch, reset everything. Then you compile it. Then it's loaded. Now it is loaded into the memory. Where? At 80. See, it's loaded. Now what is happening? Your PC is pointing at 80. The moment I start the execution, it will start from 800. Then I do another one. Now if you see, A is become 0A and the memory location of 1000 is 0A. Now I'll how it went to the A? I don't know. This should have been 0. Oh, I have a separate reset for memory also. Yeah, I didn't do that. I said only that. There's a memory. He has given the thing. I reset the memory also. Now I start from scratch. I don't want it to confuse you. I'm also learning like you sometimes. Some softwares are all you may be doing much better. Now I start from beginning. Yeah. Now you see that your PC is 800. I execute the instruction once. Then PC become 802. Just move to the second one. Then I execute this guy. Then that memory is become A. Then I see that I execute this once again. Now you see that A become 14. Then a PC become 8007. Because this is 2, this is 3, this is 2, this is 7, this is 7. If you come and see here, it will see that. You will see that below that. You see here 7. 0, 3, 2. This is 7. Now, when I see here, I'll start executing one by one. Load accumulator. Now accumulator has become once again this one. So I have not executed. Now B to A. This is what the important for us. Now what happened? This is 14 and A is this. Now, when I execute the instruction now, add B, now I got 1E, 30. But see here the flag. Only parity is set, not the carry flag. So, what I'm going to give you is a small thing what our program does. Previously we discussed. With that I stop this. Then I'll go back to the board. Now I stop it. Then I go here. I put here 129. You put here 130. Now when I reset this, then I reset the memory also. It becomes 0. Then I execute it. Because I want to show that how the carry flag is set. Then I start executing one by one. See, up to this place, carry is not set. The moment I do add B, even though it's not set, carry. But see here, I execute next instruction, carry is set. Because this one, add B sets the carry. At the same time, your accumulator became 3. Understand? This is what exactly taking place when I write a C code. My C is getting compiled like this. Now, somebody asked me that, when will I use add carry? Now, when I write a small other program, let's go to the board and see the other program. How do we write? Then you will understand. Let us see the memory also. See that? I didn't store the last one. I'm here only. The moment I put another instruction at 1002 become, see here, 81, 82, but the result is 3. Okay. It is actually 103. The 1 is at the carry bit. If you use it or don't use it is your trick. So this is what actually taking place when you write the program. So you will never believe 81 plus 82 equal to 3. Let me share the screen. Somebody some doubt. Oh, that's what I'm going to show now. I want to get the actual answer. Okay, that's exactly you asked. I'm going to do the same thing. I'm going to use this. Yeah, printf is a big program. It does inside. Printf does inside. Okay. All of them are done by printf software. We'll discuss printf later one day. That will be very nice. You will understand thoroughly how the printf works. Now, let me write a program. If you don't want, let's say you want like this, you say that char, to be sure that at the leftmost, then it'll be easy. I'll have a lot of space. Char A, B, C. A equal to 128, 129. B equal to 130. C is equal to A plus B. Okay. Is it right? I say printf. Now I want the full answer. Am I right? It's not, I don't want to do that. Then you have to change. The only way is to change this to short. You only way to change this is short. There's no other way. Or you can say char AB short C. At least that already is going to become more than 128. So there's no other way. Please, if you say that you want to display more than 255, the only way is you have to declare. You have to space one more space. Now, let me tell you what happens. I will tell you what happens. Same program, we'll see. We will write into the assembly now. Now that stores it. Does not have a thing. It doesn't matter. RHS, whatever you write in RHC, I told you already. You may say that char A is unsigned. If I say A is equal to 127, or A is equal to 255, or A is equal to 0x80, or A is equal to 0x2ff, or A is equal to 0377, that is an octal. Or you say A is equal to, within quote, single quote, some U, whatever you do, that guy never bothers. He just, this is what called RHS, this is called LHS. Okay, he will convert this into number, then put it on the LHS side. That's it. Compiler. He never bothers whether you are in binary, symbol, or hexa, or octal, or symbol. Nothing. Nothing is bothered by the C. But everything goes as a binary, 8-bit binary. Because you told me to allocate only 8-bit. Okay. You told me to allocate only this. Now, there's a trick now. Now there is a trick. What you have done is, you have defined this as a short. So I create a table now. I create a table. The table I say and A, 1000 at one location. And B, 1001. I have one location. And C, 1002, two locations. You understand? You clear? Now the trick is, I write a assembly program now, you will understand. Move immediate A, 129. I say 81H. I say move immediate B, store A, what is the thing? 1000H. I say move immediate A, 82H. 82 is 128 plus 2, 130. I say store accumulator, how much? 1001H. I storing it to B. Okay. Now what you do that? Load A, 1001. 1000. because A, I'm loading A. Then move B, comma A, I'm storing it A to B. Then I say load accumulator, comma 1001 H. Understand these few lines, you will understand clearly. Nothing more than that. Then I say that now, this is till that time everything is same, like a old program. The only trick here I'm doing here is add, okay, B. A and B added. A and B added means what? '81 plus 82. Am I right? So 81 plus 82 is what? 10000 001 1000. I get 11 0 and carry is set 1. Carry is set 1. Now my accumulator is having 03. Then what I do here is store accumulator on 1002. That is fine. Up to that, everything is okay. Now what I do, a simple case is, okay, move immediate accumulator, comma 0. I'm moving accumulator to 0. Now add A. What will happen? If you to add A means A plus A is equal to A. So 0 plus 0 is equal to 0. But unfortunately, I don't know what is the other operation. You could load any number here, not only 81. You can load 10 and 20 also. I don't know carry is set or not. So I cannot take action. I say now add carry A. Now what it does, A plus carry equal to A. So in this case, carry is set 1. So A become 1. Now I say store accumulator on 1003H. It's also C, because see here, you put short. When you create a table for A and A at 1000, and number of size is 1 byte, and B 1001, 1 byte, because it's also a character. But C, you put and C 1002, and you set how many bytes? 2 bytes, because you allocated short. Am I right? This table has to be understood. This is called symbol table. And A and B and C. 1000, 1001 and 1002. 1, 1, 2. I occupy 2 bytes in the memory. The memory, our man occupies, A occupies one byte, B occupies 2 bytes, 1 byte, but C occupies 2 bytes. And 2, this is called low byte, this is called high byte. This is called low byte, this is called high byte. When I moved this value, added here, add B and 2, this got 03. Now I got the accumulator is 1. I'm storing it on 03. This becomes 01. Now you understand how I'm storing the value in the memory 01, 03. I'm not wasting now. I'm using the carry now to store it on the memory. Is it clear? If you make this one clear, it's fine. I can write these 2 lines on the code and show the thing. Let us see the same thing here. Is it clear? If you have a doubt, let me know. How? No, somebody asked, how do I not wasting the one? Okay. Now, if you do printf, you will get 129 plus 130. Now I don't waste the carry. This is how the ADC is used. ADC is used when you do beyond 16-bit operations, 8-bit operations. We have a short. I don't want to waste it. Now let us go back. We'll see that. We'll add these two instructions now. Now we'll write the we'll clear the memory. Now we have written this instruction now. I'll stop it. Then I add here move immediate A, 0. Add A. So add CA. Store accumulator 1003H. That's it. If we execute the instruction now, let us execute the full program now. Let me reset this also. Memories also. I've reset everything now. Now I'll execute full as a full, not single step. Okay. Now I compile it and store it at the I execute full all. When I execute full, now let us see the memory. See here, 81, 82, 03, 01. You understand now how things are happening. Correct. Perfect. I'll explain that also. I will now do the same thing now. Perfectly a good question. If I do that, if you like to do that C on further operations, then we have to do higher byte, lower byte separately. I'll explain to you now the same small program. The same program I will modify now. Okay. You're right. Keep on. This is the way we should develop. The moment you ask more questions, I will give you more concepts. The question is that now these are character. So I put move immediately. Now let us do the same program. How do I do that? Let us take a small trick here. I write a program now, same program. Let's see. Move immediate. Sorry. I write on assembly, but I'm doing it on. I put char short A, comma B, comma C. A equal to 129. B equal to 120, 130. C is equal to A plus B. Printf, comma A. So I see. Now the problem is, I allocated, if you go to the symbol table, the symbol table will be like this. A and A, 1000, 2 bytes. And B, 1002, 2 bytes. And C, 1004, 2 bytes. All become 2 bytes. This is called variable or symbol. And this is called address size. Now, when I write a program, it's a trick now. Now, how do I write a program? You see that. This will be very clear. You have written move immediate A 129. (129) means 81H. That's only 8-bit. but you allocated 64-bit. I put store accumulator at 1000. So on the memory at 1000, I store 81. I say now move immediate A, 00H. Store accumulator, 1001. See that I put 00. Now you understand? By declaring the character and short, when I declare CHAR, I use only 2 instructions. When I use the same 129, you put short, you make 4 instructions. So the microprocessor have to read all the 4 instructions and it has to execute all the 4 instructions. It does same thing. If you say move immediate B, it say move immediate B, 82H. Store B, move immediate A. Store A, 1002. So at 1002, it will move 82. Then move immediate A, 00. Store accumulator, 1003. 00. Understood? So these are all the complex way. Then I have to once again load 8-bit at a time. Load accumulator A 1000 because you put C is equal to A plus B. Then I put this from 1000. Then store this value. We have to start doing that. Now I'll see that load. Then I say move B, A. Then I say store load accumulator, 1002. So 81 has come to B. Now B is having 81. Then I say add B. Then what happened? A and B are added. A is having now 82. Because I put load 1002. Then add B. 81, 82 added. Now A is having this 03. Now A is having 03. But carry is set. Carry is 1. Now the instruction comes here. The continuation. The continuation is move load, because I have added only the 81. See, now what I stored in memory is 0081, 0082. I have added now. I got 03. I set carry 1. Now this has to be added. How I added is load accumulator. What is that? 1001. This number. Move B, A. I say load accumulator 1002. 1003, sorry, this. Previously, I added low byte. Now I'm adding high byte. Now I say add carry B. Now A is having 00. Now B is having 00. Now, once again, I add 1300. When I say add carry, I add 0 plus 0 plus carry is 1. So now it becomes 01. Now I say that low store accumulator in what is the value? Oh, here I forgot store. See, add B, store accumulator in 1004. That is what your C address. Then, so we understand the table. The table has to be in your mind. This table has to be understood. That is, and A is 1000, and B is 1002, and C is 1004, because you allocate everything 2 bytes. Now store accumulator into 1005. See that? I added here the low bytes. Here I added a high byte. Okay. Then I store it. So see that how many instruction just by unnecessarily you understand that's why I'm explaining this is you should understand that why in embedded you have to be very careful using char or short. If you use character, you use less instruction. If it is a 8-bit processor, I will explain the same thing if it is in a ARM instruction. I will explain when I'm discussing ARM. I will explain the same code, how the ARM behaves. Then you will thoroughly understand the assembly. There's nothing, to be frank, there's nothing more in assembly. This is what in assembly. Okay, let me take a small break. It's only 1:10. We record, stop this session.